The concept of brain-computer interfaces, BCIs, is one of the most exciting and promising technologies to emerge in the past few decades. BCIs allow users to interact with computers and other devices by using their brain activity, such as electroencephalography, EEG, signals. This technology has the potential to revolutionize the way humans interact with technology, and to open up new possibilities for medical treatments, education, and entertainment. Despite its great potential, however, BCIs are still far from being widely used or accepted. This is due in part to the complexity of the technology and its lack of widespread understanding by the general public. In this article, we will explore the complexities of BCIs and discuss how they can be used to improve the lives of people with disabilities and those suffering from neurological disorders. The first complexity of BCIs is the complexity of the brain itself. BCIs rely on the ability to decipher electrical signals from the brain, which can be incredibly difficult to do accurately. These signals are generated by neurons firing in different patterns, and are known as brain waves. Since every person's brain is different, it is necessary to create algorithms to interpret these signals in order to make sense of them. Another complexity of BCIs is the need for specialized hardware. EEG electrodes must be placed on the scalp in order to detect the electrical signals from the brain, and these signals must be amplified and processed before they can be used. While this hardware is becoming increasingly accessible, it is still relatively expensive and difficult to set up. The third complexity of BCIs is the difficulty of creating meaningful applications and interfaces. BCIs are still very much in their infancy, and much of the research is focused on basic applications, such as controlling a cursor on a screen or playing a simple game. Creating more complex applications requires a great deal of research and development, and there is still much to be learned before BCIs can be used to create immersive and interactive experiences. Despite these complexities, BCIs are still a promising technology that has the potential to improve the lives of people with disabilities and those suffering from neurological diseases. BCIs can be used to allow people with paralysis, for example, to control a computer or robotic arm with their thoughts. Similarly, BCIs can be used to help people with Alzheimer's disease or other cognitive impairments to communicate more effectively with their caregivers. In addition to medical applications, BCIs can also be used to improve the educational experience. BCIs can be used to create interactive learning tools that adapt to the user's individual needs and provide feedback on their progress. BCIs can also be used to monitor a student's emotional state, allowing teachers to intervene if needed. Finally, BCIs can be used to create immersive and interactive entertainment experiences. BCIs can be used to create virtual and augmented reality experiences that respond to a user's thoughts and emotions. This could be used to create video games, educational experiences, and other interactive experiences. It is clear that BCIs offer a great deal of potential, but the technology still has a long way to go before it can be widely used and accepted. The complexities of the technology, the need for specialized hardware, and the difficulty of creating meaningful applications are all major obstacles that must be overcome with continued research and development. However, BCIs can become an important part of our lives and help improve the lives of people with disabilities and those suffering from neurological diseases.